Download this code from codegive.com, link in the description below. OK, let's delve into why many developers struggle with unit testing and how to improve your approach. We'll cover common pitfalls, best practices, and illustrate with code examples in Python, easily adaptable to other languages. Why you suck at unit testing, a deep dive. Unit testing, when done well, is a cornerstone of robust, maintainable software. It allows you to catch bugs early, refactor with confidence, and improve the overall design of your code. However, many developers find it challenging, leading to tests that are brittle, useless, or simply never written. Here's a breakdown of the common reasons and how to overcome them. 1. You don't understand what a unit actually is. The problem the most fundamental issue is a fuzzy understanding of what constitutes a unit in unit testing. Many treat a unit as an entire class, a large function, or even a module. This leads to complex tests that are difficult to write and maintain. The solution definition a unit should be the smallest testable part of your application. Ideally, this is a single function or method within a class. Focus on single responsibility. If your function is doing too much, it's a sign that it's not a proper unit. Refactor it into smaller, more focused functions. The single responsibility principle, SRP, is key here. Avoid testing implementation details. Unit tests should focus on the behavior of the unit, not its specific implementation. Testing implementation details makes tests brittle and prone to breaking when you refactor, even if the behavior is unchanged. Example. This function does way too much. It's nearly impossible to unit test effectively because a single failure can stem from multiple causes. Now validate _order, update _inventory, process _payment, and send confirmation email are much smaller, testable units. We can isolate their behavior. Note that even process _order itself can be tested, but now in terms of whether it correctly orchestrates the other functions. 2. You're not using mocks and stubs correctly, or at all. The problem your tests are tightly coupled to external dependencies like databases, APIs, file systems, or other complex classes. This makes tests slow, unreliable, and difficult to set up. You can't easily isolate the unit under test. The solution mocks versus stubs understand the difference. Stubs provide canned responses for dependencies. They're simple replacements. Used primarily to provide data the unit needs. Mocks more sophisticated. They allow you to verify that interactions with dependencies occur as expected. Example: a method was called with specific arguments. Mocks are used to check behavior. Dependency injection pass dependencies into the class or function being tested, rather than hard-coding them. This allows you to easily substitute mocks or stubs in your tests. Mocking libraries use a good mocking library. In Python, unitest.mock, part of the standard library, and ptestmock are excellent. In Java, you have Mockito, EasyMock, PowerMock. C has mock, and substitute, etc. Example. In the good example, we create a mock object to stand in for the real database connection. We then stub the execute _query method to return a specific value. Crucially, we can also use assert called once with to verify that the execute query method was called with the expected SQL query. This verifies the behavior of get user name. 3. You're not writing tests first, or early enough. The problem writing tests after you've already written the code is a common pitfall. You tend to write tests that simply confirm what the code already does, rather than driving the design. You also may unconsciously avoid testing edge cases that you know are difficult to handle. The solution test-driven development, TDD. Embrace TDD. The TDD cycle is 1. Write a failing test. Define the desired behavior of the unit. This test should fail initially because the code doesn't exist yet. 2. Write just enough code to make the test pass. Focus solely on satisfying the test. Avoid over-engineering. 3. Refactor. Clean up the code, improve its structure, and remove duplication, while ensuring that all tests still pass. Benefits of TDD. Better design. Forces you to think about the API and behavior of your code before you write it. Comprehensive testing. Ensures that you have tests for all the functionality you implement. Reduced bugs. Catches bugs early in the development cycle. Incremental testing. If you're not ready for full TDD, at least write the tests concurrently with the code. As you implement a feature, immediately write the tests to verify it. Example. Let's say you want to write a function that calculates the area of a rectangle. TDD approach. 1. Write a failing test. 2. Write the code to make the test pass. 3. Refactor. In this simple case, there's not much to refactor. But in more complex scenarios, you would now look for ways to improve the code's structure and readability. 4. Your tests are too brittle. The problem. Your tests break every time you make even a minor change to the code, even if the overall behavior hasn't changed. This is a sign that you're testing implementation details rather than behavior. The solution. Focus on public API. Test the public methods and properties of your classes. Avoid testing private methods or internal state directly. Treat your unit as a black box, you only care about what goes in and what comes out. Avoid asserting on specific return values where possible. Instead of asserting on specific return values, consider using more abstract assertions. For example, instead of asserting that a list contains a specific element at a specific index, assert that the list contains the element, regardless of its position. Test against interfaces, or abstract classes. If you're working with polymorphism, test against interfaces or abstract classes rather than concrete implementations. This makes your tests more resilient to changes in the concrete classes. Mock external dependencies effectively. As explained above, use mocks to isolate your units from external dependencies. If you're testing interactions with dependencies, focus on what messages are sent, not how they are sent. Example. The brittle test directly accesses the private _name attribute. If we refactor user profile to store the name differently, example using a different variable name, the test will break, even though the behavior of get_greeting is unchanged. The robust test only tests the public API, get_greeting, making it more resilient. 5. You're not writing enough tests, or the right kind of tests. The problem. You only write tests for the happy path, the normal, expected behavior, and ignore edge cases, error conditions, and boundary conditions. This leaves your code vulnerable to unexpected failures. The solution. Think about all possible scenarios. Before writing code, brainstorm all the possible inputs, states, and conditions that your unit might encounter. Test for edge cases. Test with null values, empty strings, very large numbers, zero values, and other edge cases. Asterisk test for error conditions. Asterisk test that your unit handles exceptions and errors gracefully. Asterisk boundary value analysis. Asterisk test the values at the boundaries of input ranges. For example, if a function accepts a number between 1 and 10, test with 1, 10, and values slightly outside the range, 0 and 11. Asterisk equivalence partitioning. Asterisk divide the input domain into equivalence partitions, where all values within a partition are expected to behave the same way. Test one value from each partition. Asterisk code coverage tools. Asterisk use code coverage tools, example coverage.py in Python, to identify parts of your code that are not being tested. Aim for high, but not necessarily 100%, coverage. Coverage is a guide, not a goal in itself. Asterisk example asterisk. The incomplete test only covers the basic case. The complete test adds tests for division by 1, negative numbers, 0, and division by 0, which should raise an exception. 6. Your test setup and teardown is a mess. Asterisk the problem. Asterisk setting up the test environment, example creating test data, configuring dependencies, is complex, repetitive, and tightly coupled to the tests. Tearing down the environment, example cleaning up data, closing connections, is often forgotten, leading to resource leaks or interference between tests. Asterisk the solution. Asterisk. Asterisk test fixtures. Asterisk use test fixtures to set up and tear down the test environment. Most testing frameworks provide mechanisms for defining fixtures. Asterisk setup and teardown methods. Asterisk use setup and teardown, or equivalent methods in your testing framework, to perform setup and teardown operations for each test. These methods are automatically called before and after each test. Asterisk setup class and teardown class methods. Asterisk use setup class and teardown class, or equivalent, to perform setup and teardown operations that are shared across all tests in a test class. These are executed only once for the entire class. Asterisk factories. Asterisk use factories to create test data. Factories allow you to create objects with default values and customize them as needed for specific tests. Asterisk example asterisk. In this example, setup creates a temporary file, and teardown cleans it up. This ensures that each test runs in a clean environment. 7. Your tests are slow. Asterisk the problem. Asterisk your test suite takes too long to run, which discourages you from running it frequently. This defeats the purpose of unit testing, which is to provide rapid feedback. Asterisk the solution. Asterisk. Asterisk isolate your units. Asterisk as mentioned earlier, use mocks and stubs to avoid hitting external dependencies like databases and APIs. Asterisk parallel execution. Asterisk use a testing framework that supports parallel test execution, example ptest in Python. Asterisk optimize database interactions. Asterisk if you must use a real database for some tests, use transactions to quickly roll back changes after each test. Consider using an in-memory database, example SQLite, for faster testing. Asterisk test only what's necessary. Asterisk avoid testing things that are already thoroughly tested by libraries or frameworks. Focus on testing your own code. Asterisk profile your tests. Asterisk use profiling tools to identify the slowest tests and focus your optimization efforts on those. 8. Your tests are poorly named and organized. Asterisk the problem. Asterisk your test names are cryptic, your test classes are disorganized, and it's difficult to understand what each test is supposed to be doing. Asterisk the solution. Asterisk. Asterisk descriptive test names. Asterisk use clear, descriptive names for your tests that explain the scenario being tested. A good test name should follow a pattern like test _ method _ name _ scenario _ expected _ outcome. Asterisk organize test classes asterisk group related tests into test classes. Use a consistent naming convention for your test classes, example test class name. Asterisk use comments sparingly asterisk good test names should make the test self-documenting. Use comments only to explain complex or unusual scenarios. Asterisk follow a consistent style asterisk adhere to a consistent coding style for your tests, just as you do for your production code. Asterisk example asterisk. The good test naming example uses more descriptive names that clearly indicate what each test is verifying. 9. You're afraid to refactor because of your tests. Asterisk the problem asterisk you have tests, but they are so tightly coupled to the implementation that any attempt to refactor the code results in a cascade of failing tests. This makes you reluctant to refactor, leading to code that becomes increasingly difficult to maintain. Asterisk the solution asterisk. Asterisk write tests that focus on behavior, not implementation asterisk as emphasized throughout this guide. Your tests should focus on the observable behavior of your units, not their internal implementation details. Asterisk refactor in small steps asterisk when refactoring, make small, incremental changes and run your tests after each change. This allows you to quickly identify and fix any issues. Asterisk don't be afraid to rewrite tests. Sometimes if your tests are truly preventing you from refactoring, it may be necessary to rewrite them. This is especially true if the tests are testing implementation details or if the code has undergone significant changes. Asterisk trust your tests, but trust that your tests are giving you accurate feedback. However, it's always a good idea to manually verify that the behavior of the code is as expected after refactoring. 10. You don't treat your tests as first-class code. Asterisk the problem asterisk you treat your tests as an afterthought, writing them quickly and without much care. This leads to tests that are poorly written, difficult to understand, and unreliable. Asterisk the solution asterisk. Asterisk apply the same standards asterisk treat your tests with the same care and attention to detail as your production code. Follow the same coding style guidelines, use meaningful variable names, and write clear, concise code. Asterisk refactor your tests asterisk just like production code, tests can benefit from refactoring. Look for opportunities to simplify your tests, remove duplication, and improve their readability. Asterisk version control asterisk store your tests in version control alongside your production code. Asterisk code review asterisk have your tests reviewed by other developers to catch errors and improve their quality. Key takeaways asterisk. Asterisk understand the unit asterisk define what a unit is in your context and keep your units small and focused. Asterisk mock dependencies asterisk isolate your units from external dependencies using mocks and stubs. Asterisk test early, or first write tests before or concurrently with your code to drive the design and ensure comprehensive testing. Asterisk test behavior, not implementation asterisk focus on testing the observable behavior of your units, not their internal implementation details. Asterisk test all scenarios asterisk test for edge cases, error conditions, and boundary values. Asterisk organize your tests asterisk use clear test names, test classes, and test fixtures to keep your tests organized and maintainable. Asterisk treat tests as first-class code asterisk apply the same coding standards and practices to your tests as you do to your production code. By addressing these common pitfalls and adopting best practices, you can significantly improve the quality of your unit tests and build more robust, maintainable software. Good luck.